Hi everyone, bonjour. The IB Crocodile is here. Welcome to my YouTube channel. Today, let's go through this past paper question, paper 1, physics high level, time zone 1, May 2023, number 13. The same question appeared in the SL, the standard level paper, also paper 1, May 2023, but it was number 16 in paper 1 SL. So let's have a look. A group of students perform an experiment to find the refractive index of a glass block. They measure various values of the angle of incidence, I, so they call it I, angle of incidence, and angle of refraction, R, for a ray entering the glass from air. A ray entering the glass from air. They plot a graph for the sine R against sine I, and we can see here it's a straight line passing by the point of origin. Now, they determine the gradient of the graph to be m. Okay. Which one of the following gives the critical angle of the glass? So this question here is about refraction, and it is also about the critical angle. So let's break it down step by step. So first of all, let's remember, what do we know about refraction? Refraction is a phenomena of waves, when a wave passes from one medium to another. So there is a change in the direction of propagation due to the change in speed according to the optical density of each medium. So these two media here have different optical density, and we call it, we can describe it by the refractive index of each medium, right? And since they have different refractive indices, they basically have different speed, and that's why the incident ray will change its direction of propagation, and that would be a refracted ray in the medium. Now, in the question, it mentioned, the ray entering the glass from air. So let's say we have air here, we have glass there, and we can use Snell's law to find, the relationship between the refractive indices, and of course the angle of incidence and angle of refraction. So Snell's law says n1 over n2 equals to sine theta 2 over sine theta 1. This is in your booklet. But then also, theta 2 is basically theta r here, which is the angle of refraction divided by the sine of the theta I, the angle of incidence. Now we know n1 of air. Let's say n1 of air here is 1, the reference, right? And I'm going to call n2 just n sub g, where like sub g for the glass, right? Now applying Snell's law, so n1 over n2 equals to sine theta r divided by sine theta I. Okay, so now let's apply this in the question here, right? So n1 is basically air, so I will say 1 over n2, which is n sub g, equals to sine. Now the angle of refraction, he called it r, so instead of theta r, he just called it r. Sure, typical IB. And then angle of incidence, he called it I. So we can say here 1 over n sub g equals sine r over sine I. Snell's law, straight application. Now the gradient of this curve here, of this curve or this straight line here, is going to be delta y over delta x, right? But since it starts from the origin, so I can say right away y over x. It's okay, y minus 0 over x minus 0, right? So the gradient here, let's say, okay, the gradient is going to be whatever on y, which is sine r, divided by sine I, which is on the x-axis. Now he called the gradient m, sure. So sine r over sine I is m. And actually, we just used Snell's law here, and we found sine r over sine I is 1 over n sub g. So that means what? That means m is 1 over n sub g. Make sense? Let's call it equation 1, right? I mean, if this side here equal m and that side is the same as 1 over n sub g, so that means this side equals to that side, right? Now, there is a switch here in the question, and that is really a trick. Because now he says, okay, which of the following gives the critical angle of the glass? So why I said a switch here? So let's remember our information about the critical angle and the total internal deflection. The critical angle, by definition, is the angle of incidence. Again, is the angle of incidence for which the angle of refraction is 90 degrees. When a wave passes from a more optically dense medium to a less optically dense medium. This is full definition of a critical angle. And the key word here is what? The key word is the situation happened when the wave or the light passed or passes from more optically dense to a lower or to a less optically dense, which means here we're gonna switch Snell's law. Here N1 is going to be the glass. So for example, incident medium here is the glass, so it's not from air here. This time we're gonna switch. So the ray has to pass from glass to air. Okay, so let's apply that. So again, Snell's law, but from glass to air. So N1 over N2. Okay, I'm rewrite it again. Equals sine angle of refraction divided by angle of incidence, right? Sine R over sine I. But then N1 here is going to be N sub G, because this would be our first medium, you know, from glass, from more optically dense, over N2 towards air, which is 1. Now, angle of refraction for critical angle is 90 degrees. So sine 90 degree, and we know sine 90 is 1. And then divided by sine I, now I'm going to call it theta sub c, because I here is the angle of incidence, which is the critical angle. Now let's do some simplifying here. So sine 90 is 1. So we can say 1 times 1 is n sub g times sine theta sub c equals to 1. I just did cross multiplication here. 1 by 1 equals, you know, cross multiplication n sub g times sine theta c. Theta sub c. So now we can separate theta sine theta sub c is 1 over n sub g, and let's call it this equation 2. Now from 1 and 2, if we know that 1, or we prove together that 1 over n sub g is m, is the gradient, and also sine theta sub c is also 1 over n sub g, so the conclusion is sine theta sub c is equal to m, right? So from 1 and 2, we can say sine theta sub c equals to m. Now I need only the critical angle, so you take arc sine of the right hand side, so arc sine or sine minus 1, right, of m. So that is the angle, I mean the critical angle of the glass. So the final answer of this question is A. The same question was number 16, as I mentioned before, 16 in paper 1 SL May 2023, time zone 1. Okay, the bottom line, every time you see critical angle or total internal reflection, okay, you have to keep in mind the ray has to pass from a more optically dense medium to a less optically dense medium. Thanks for watching. Feel free to leave comments, any comments, likes, subscribe if you see it is helpful to you, and have a nice day.